The Bliss Modulo 6 auto transporter is designed for the efficient transport of up to 6 vehicles. It features a hydraulically tiltable rear platform, allowing for smooth and controlled loading and unloading. The upper tiltable platform provides additional vehicle capacity and flexibility in positioning. The main platform can be extended to accommodate longer vehicles, while hydraulically adjustable ramps ensure optimal alignment and slope during loading operations. This advanced trailer is ideal for professional use, offering both robustness and operational convenience. The combination of a tiltable structure and modular design makes it a versatile solution for the automotive transport industry. The Langendorf saddle deflator is a specialized low-bed semi-trailer engineered for the professional transport of construction machinery. Designed for worldwide deployment, the trailer ensures high safety standards across all operations. Its low loading height provides easy access for loading and unloading heavy equipment, while the open and clearly arranged platform layout enhances operational visibility and efficiency. Built with robust materials and optimized geometry, the saddle deflator offers a secure and stable platform for transporting oversized or heavy-duty machinery. Quick deployment, ease of handling, and a focus on operator safety make this trailer ideal for demanding construction logistics across global job sites. The Langendorf Papier Innenlader is an engineered solution for the efficient and secure transport of paper rolls in high-volume logistics operations. The trailer integrates a fully lowerable chassis system that enables fast, ground-level loading and unloading, minimizing downtime and operational delays. Designed to accommodate variable roll dimensions, up to 1,450 millimeters in diameter and 3,500 millimeters in height. The structure is equipped with a certified load securing system, ensuring compliance with transport safety standards while protecting sensitive cargo from deformation or displacement during transit. Engineered for minimal load impact, the unit is optimized for consistent transport quality, particularly in paper and packaging sectors. The system's modular design enhances operational versatility, and all loading operations can be executed with a high degree of repeatability and efficiency. With over 30 years of experience in specialized vehicle design, Langendorf combines proven mechanical engineering with practical handling features to deliver a high reliability in Hamar self-loading trailers handle 36 tons in 3.5 minutes with safe 2+2-point lifting. Trusted worldwide since 1974, they offer versatile configurations, operator safety, and secure loads using durable twist locks for fast, reliable operations. The universal low loader from Schroeder Fahrzeugtechnik is designed for special transports, handling overwidth or overweight loads with ease. Equipped with hydraulic double ramps, sliding roof, side extension, insertable table, hydraulic lift bed, building ramp loading prep, and a winch, it's fully versatile. PipeMaster eStop provides emergency stop functions for pipe handling systems, ensuring operator safety with quick, reliable shutdown during critical operations. The Liebherr LR 11350 crawler crane with power boom lifted a 378-ton, 6 megawatts wind turbine nacelle onto a 110-meter tower in Eemshaven, Netherlands. Operated by Weldex, the crane's enhanced stability and capacity allowed for a single, efficient lift, streamlining the installation process and reducing assembly time in wind power construction. Liebherr has introduced an innovative method to improve the assembly of the LR1600 halves crawler crane, particularly when equipped with long boom systems for wind power applications. By using the LTR-1220 telescopic crawler crane as a mobile counterweight, the setup process becomes significantly more efficient and safer. This solution eliminates the need for large suspended counterweight systems and simplifies crane erection in confined spaces. The LTR-1220 assists by providing ballast support during key stages of boom installation, reducing time and logistical effort. This approach enhances operational flexibility and improves overall safety on wind farm construction sites. The assembly process of the Liebherr R960 demolition begins with preparing a stable ground surface and mobilizing heavy lifting equipment. The 240 kilowatts diesel engine is then mounted in the rear engine compartment. Its robust structure, long reach, and efficient hydraulic system make it suitable for dismantling tall structures while maintaining stability and control. The crawler undercarriage is installed and secured. The main upper structure, which includes the cabin and control systems, is placed onto the undercarriage. Once the main body is aligned and fixed, the demolition boom and stick are assembled and hydraulic lines and connections are completed. Behind the scenes at Hitachi Construction Machinery, Europe's factories in the Netherlands, precision and efficiency define every stage of the manufacturing process. In Amsterdam, where around 300 employees work, the focus is on assembling crawler and wheeled excavators, medium wheel loaders, and special application machines. The site consists of two main buildings, Factory A, 30,000 square meters for assembly, and Factory B, 20,000 square meters for component fabrication. In Factory B, raw plates and parts arrive and are processed through a welding sequence that begins with tack welding, followed by full manual or robotic welding. The robotic systems offer high accuracy, and weld quality is verified by skilled technicians before proceeding to painting. All painted components are sanded, filed, and suspended on the component paint line. A dust-separating wall and an active suction system ensure a clean environment, particularly to protect hydraulic components. Components receive an epoxy primer and, while still wet, a top coat is applied. Bright LED strip lighting aids in quality checks at each phase, from welding to painting to final inspection. In Factory A, excavator assembly begins with upper structures imported from Japan. These are fitted with customer-specific modifications, such as lighting, mirrors, sun visors, seat options, hydraulic adjustments, and undercarriage variations like track shoe width. Assembly workstations are supported by purpose-built carts and a train-like vehicle with 6 wagons, which distribute components throughout the factory. A high-precision torque tool secures swing bearings, ensuring reliability and reducing physical strain. Employee-developed protective solutions, like arm and boom covers, help prevent damage during assembly, minimizing the need for rework. The factory also has a dedicated Kaizen area for continuous improvement, where workers can prototype new tools and efficiency aids. In the final stage, machines undergo functional testing to check for hydraulic leaks, pressures, and operational speed. A last inspection under strip lights ensures cosmetic quality and exact specification compliance before delivery to the customer. The Hitachi Construction Machinery Factory in Amsterdam is a state-of-the-art facility dedicated to the production and assembly of excavators and wheel loaders. Established in 2001, the factory covers approximately 50,000 square meters, split between two main areas: a component manufacturing plant and an assembly plant. The component plant specializes in fabricating critical parts such as undercarriages, arms, and upper structures, including cabins. The manufacturing process begins with tack welding to hold components in place, followed by full welding performed either manually or by robotic systems. Each weld undergoes rigorous inspection by certified final welders to ensure compliance with strict quality standards. Following welding, the components are prepared for painting. Surface preparation includes sanding and puttying to create a smooth finish. A multi-layer painting process follows, beginning with an epoxy primer for corrosion resistance. The top coat, applied wet on wet, features Hitachi's signature orange color, delivering a durable and visually consistent finish. This process enhances both the longevity and aesthetics of the machinery. Since 2008, the factory has implemented lean manufacturing principles to minimize waste and optimize efficiency. This strategy allows production to be closely aligned with customer orders, reducing inventory levels and eliminating unnecessary production. By producing only what is needed, the factory reduces material waste and improves lead times, resulting in a more responsive supply chain. The assembly plant handles both crawler and wheeled excavators, with wheel loaders divided into compact and mid-size models. Assembly modifications can be made to the upper structure, such as cabin features including seats, lighting, and sunshields, as well as to hydraulic systems and undercarriage components like track shoes of various widths. Machines are assembled either from raw components or from semi-finished units, and some specialized models are imported and finished on-site to meet specific customer requirements. The layout of the factory is optimized for excavator production, with a reversed assembly flow for larger wheel loaders, such as the ZW310, to enhance safety and efficiency. The workforce includes around 210 production and logistics employees, supported by approximately 60 staff in engineering, quality assurance, and production control. The factory operates with high levels of traceability and digital monitoring across all stations. Environmental sustainability is a core focus. The factory separates waste streams, including wood, steel, paper, plastics, and chemical waste, for proper disposal and recycling. Recent improvements in wastewater treatment involve filtration technology that reduces water consumption and environmental impact. Before delivery, each machine undergoes thorough functional testing to check hydraulic systems for leaks, pressure levels, and operational speeds. The final inspection ensures the machine's cosmetic condition is flawless, free from scratches or rust, and confirms all technical specifications are met. This rigorous quality control process guarantees that Hitachi machines from Amsterdam are reliable, safe, and ready for demanding construction work. The Dressta TD40 extra-cooled dozer is the largest and most powerful machine in Dresta's range of 9-track type crawler tractors, weighing over 60 tons. This heavy-duty steel machine is manufactured in Huta Stalowa Wola, HSW, Poland, a facility with over half a century of expertise in construction equipment. HSW began in partnership with International Harvester and Dresser, and today, Dressta machines bear little resemblance to the early licensed models. Over the decades, they have undergone multiple phases of modernization to meet evolving technical and market requirements, with a continued focus on high performance, reliability, ease of operation, and serviceability. All development begins in the engineering department, where specialized CAD software is used to design standard and customized models, including crawler tractors, pipe layers, wheel loaders, and backhoe loaders. These designs are tailored for various conditions such as high or low temperatures, desert climates, or landfill operations. A significant advantage for Dressta is the in-house design and production of special attachments, ensuring complete integration and system reliability rather than depending on third-party suppliers. Production begins in the sheet metal department, where structural components like cabs, tanks, and platforms are cut from steel sheets using precision laser cutters, with tolerances down to 0.2 millimeters. Plasma cutting systems are used for thicker components up to 25 millimeters, offering speed, accuracy, and cost efficiency. After cutting, parts go to CNC machining centers for milling and boring operations on key elements like track frames, equalizer bars, push arms, and rear frames. This machining ensures accurate fit-up in later stages of assembly. Next is welding, where the main frame of the crawler dozer is fabricated in a rotary fixture. Components such as sidewalls, cross tunnels, and machined frames are welded into a single structure. The equalizer bar cross tunnel serves as a critical mounting base for the undercarriage system. Simultaneously, drivetrain components, torque converters, transmissions, steering units, and final drives are manufactured and assembled in dedicated departments. All components undergo thorough washing and drying before moving to the paint shop. They are first primed, then coated with a high-durability polyurethane paint designed to resist wear and environmental damage. After drying, the parts are sent to final assembly. One of the more complex steps is the installation of pivot shafts, which requires heating the frame bore to 250 degrees Celsius for thermal expansion. Once cooled, the shafts are securely locked in place. Assembly then progresses with the integration of core modules. The modular design of the transmission engine, a Cummins 19-liter unit rated at 560 horsepower, torque converter, final drives, and multi-unit cooling system, enables fast installation and simplified serviceability. Before installation, all parts undergo rigorous testing, and any components sourced externally are subjected to stringent inspection and documentation checks by the quality assurance team. Each step is logged in the machine's build record and must be formally signed off. Once the powertrain and mainframe assemblies are complete, the operator's platform is mounted. This includes an ergonomic seat, intuitive control systems for blade and ripper operations, and the fuel tank. Blade lift cylinders are installed at the front of the mainframe, followed by mounting of the undercarriage system. The heavy-duty track frames and track chains are pre-assembled and installed using split master links that enable quick and easy field maintenance. Each assembled machine is subjected to a full battery of functional tests. Pressure and steering are verified on hydraulic test stands, and every gear ratio is tested during static evaluation. A separate stand is used to detect leaks and validate hydraulic system integrity. Depending on the customer's specification, attachments like blades and rippers are installed for field testing. These may be removed prior to shipment and sent separately to facilitate transportation. The last stages include the fitting of protective engine and operator cab covers, decals, safety warnings, and the final ROPS six-sided cab. Quality assurance doesn't end with assembly. A random selection of completed units undergoes offline testing on dedicated proving grounds to simulate real-world operating conditions. All operational systems, steering, hydraulics, and power delivery, are reviewed for compliance and performance. After final inspection and testing, the machines are returned to the paint booth for a touch-up coat and application of branding and safety labels. The TD40TE extra-cooled dozer is then prepped for shipment, with the blade typically disassembled to reduce transport size. Loaded onto a truck or rail car, the completed unit is dispatched either directly to the customer or to the port for international delivery, ready for action in some of the world's toughest terrains. Liebherr France SAS in Colmar is the competence center of the Liebherr Group for the development and manufacturing of crawler excavators ranging from 14 to 100 tons. The production process is tightly controlled, from engineering design to final assembly, ensuring high mechanical precision and long-term reliability. Everything begins in the R&D department, where engineers use FEM simulation software to analyze stress distribution, optimize structures, and enhance performance in demanding job site conditions. The undercarriage, boom, and operator cab are fabricated using CNC laser cutting and robotic welding technologies. These automated systems increase dimensional accuracy, reduce assembly tolerances, and ensure consistency across all units. In the welding workshop, critical load-bearing joints are performed by robotic arms and then inspected via ultrasonic testing to detect any micro-defects invisible to the naked eye. Once structural assemblies are complete, they are transferred to the painting line, where a two-layer epoxy coating is applied to resist abrasion and corrosion. Final assembly takes place on a semi-automated line, where modules such as the Liebherr diesel engine, hydraulic systems, control electronics, and operator cab are sequentially installed. Electronic components are calibrated on-site using proprietary Liebherr software, ensuring precise control of all machine functions. Each excavator then undergoes a complete series of functional tests at an in-house proving ground. As part of the Liebherr-Riemann program, engine remanufacturing begins with complete disassembly of used components. Each part is carefully removed, cataloged, and subjected to initial inspection. Reusable components are stripped of old paint using chemical or abrasive methods, then cleaned through high-pressure washing or ultrasonic baths to remove contaminants and residues. Following this, parts undergo detailed appraisal, including dimensional checks, hardness testing, and crack detection to determine suitability for reuse. Worn or damaged components are replaced with new Liebherr-certified parts. Once approved, the reusable parts are reprocessed, machined, honed, or resurfaced as needed to restore original tolerances. The engine is then reassembled in clean room conditions with precision tools and torque specifications strictly followed to ensure optimal performance. The remanufactured engine undergoes rigorous quality control and performance testing to match the reliability of a brand new unit. Upon completion, the component is assigned a full warranty, offering customers a cost-effective and environmentally responsible alternative to new engine replacements. At Caterpillar's Athens, Georgia facility, the production of Cat Mini excavators and small dozers follows a strict built-in quality BIQ process to ensure durability, reliability, and performance. The manufacturing journey begins with precision cutting and machining of steel components using advanced CNC equipment. Frames and structural parts are robotically welded in climate-controlled bays, ensuring consistent penetration and weld quality. Each weld undergoes inspection, including ultrasonic and visual tests, to meet Caterpillar's global quality standards. Once welded, components move to the paint line, where they are cleaned, primed, and powder-coated for corrosion resistance and finish durability. In the subassembly stage, powertrains, hydraulics, and electronics are integrated into modular assemblies. Each subassembly is pre-tested before installation to verify function and integrity. During final assembly, machines are constructed on a moving production line using standardized torque tools, RFID tracking, and quality check stations, while companies stick their workers' logos on car parts. After assembly, each unit enters a functional test area, where the engine, hydraulics, and control systems are tested under simulated working conditions. Operators assess machine response, fluid pressures, temperatures, and electronic systems. Any deviation triggers immediate correction. The final inspection includes a detailed audit of fit, finish, labeling, and configuration compliance. Caterpillar's Athens plant integrates BIQ principles at every step, empowering employees to halt production if quality standards are not met. Every Cat Mini excavator and small dozer leaving the facility is ready for the toughest jobs. The ARCMAN Structural Steel Welding Robot System with FCAW, designed for seismic applications, delivers high-efficiency automation with precision and reliability. The process begins with workpiece loading, setting, and clamping, followed by user-friendly operator input via an intuitive screen. Workpiece data is easily entered into the remote operation system. Upon robot startup, wire touch sensing locates the welding seam precisely for accurate base plate welding with minimal spatter. The robot seamlessly switches tools from welding torch to slag removal tool, enabling automated slag cleaning. The positioner rotates the workpiece to the optimal welding angle, ensuring high weld integrity. Automatic nozzle and torch cleaning is performed before the wire is cut to the ideal stick-out length, preparing the system for the next weld. The cycle continues with shear plate welding, optimizing speed and consistency for structural steel components under seismic demands.